in China, specializing in the research and development of satellite technology application, such as that in remote sensing and battle navigation and all the other industries related to remote sensing technology. But we also provide professional services, including the software system research and development, the technical consultation, system design, and integrated geospatial solutions for various applications, such as that in the industry of meteorology, of marine, of water conservancy, land use, forestry, agriculture, environment, emergency and the disaster response and quick emergency rescue, surveying and mapping, navigation, and so on. And above all of that, after years of accumulation in the remote sensing software development area, and also combining with all the achievements we have made in the software as a service solutions, we have emerging all of that into the PyEngine platform that we have achieved today, which is the basic idea is to put everything on cloud, including the data, the algorithms, all the resources, the computing resources, and all the existing applications. Put everything on cloud so that users, they don't need very high level of remote sensing knowledge, or they don't necessarily have a very high performance computer, or already have access to large volume of remote sensing data. All they need to do is have access to the internet, and they will be able to use remote sensing technology and to do some data processing analysis and create their own work, their own products. So this is the list of the content for this part today. There are 4 parts overall. I'll start from the rationales of the platform, and especially behind the research and development, outstanding features of the platform. I'll move to highlights, like what is the platform is capable of doing, and up next I'll move to some to the 6 PaaS platform as a service modules, and to give you a better understanding of what this platform is consist of, and finally move on to the real life cases. So we'll start with the first part, rationales. Throughout years of development in the remote sensing area, the increasingly advanced technologies are driving explosive growth in the remote sensing data and its corresponding solutions. However, the operational applications of the data of the module of solutions tend to somehow lag behind the emerging technologies and the remote sensing data that is available to us all. One of the reasons behind this could be the enterprises who have been unable to sufficiently utilize such opportunities. On the one hand, the resources led to such information are unknown to many enterprises, especially for small enterprises. On the other hand, the utilization of such enormous database requires sufficient support, either by financial direction, or they have to have access to the advanced technology to use this. So these 2 major limitations from new or enlarge the existing gaps between the data and the computation and the industrial solutions. Under this bigger picture, PyEngine is hereby expected to address the current dilemma faced by the enterprises by means of providing with secure resources which can guarantee the sustainable development. So as you can see, we want to by using PyEngine, this platform, we want to remove the barrier between data and applications for general users, for anyone, so that they can have their tasks, have their requirements satisfied in terms of processing remote sensing data. As a result of those about that, the fundamental reasons can be summarized from the two directions, both internal and external forces. The internal forces are to address the urgent need for a one-stop remote sensing big data application, which the current low level of popularization among people who have no academic knowledge, and the urgent need for the autonomous and the controllable remote sensing science big data applications platform. So as on the other hand, as the external aspects, like there are some products like the existing Google Earth engine, which has already efficiently solved most of the internal concerns that we mentioned above and has been massively recognized and utilized worldwide. However, there are certain obstacles faced by us users, such as for most Chinese users, the VPN stability and the restriction standards can be critical, can be very annoying when you want to have access to Google Earth Engine or some other similar products. Moreover, products like GE can be regarded as the monopoly, which is too hard to compete with for us. And also, confidentiality regarding the satellite data is our research priority, which cannot be highly guaranteed by engines overseas. So above all of that, we come up with this product, PyEngine tools, and we want to at least partly solve some of the obstacles and enable users to have more options. About the functions of PyEngine platform, it takes advantages of the cloud service, such as realized in its high efficiency, its low threshold, its low cost, and easy to access. All those characteristics to explore the full value of massive spatial data and helps the decision makers with fine supervision and decision making. It can not only provide access interfaces for foreign, for example, for foreign Landsat series, Sentinel series satellite, remote sensing data, and also for our Chinese high-resolution series, the environmental series, resource series, and other satellite remote sensing data. Not just that, this platform can also contain a large number of remote sensing general algorithms and semantic algorithms. For example, based on multi-temporal Landsat and Sentinel data, analysis and processing, such as when you want to monitor crop growth, or regional drought analysis, water body change analysis, and urban change monitoring. All of those can be achieved in real time if you want to do that in PyEngine. Outside users can, on the other hand, can process several services on this platform as well. But at the same time, PyEngine is an independent online computing algorithm which can guarantee the processing smoothly. It integrates the real-time distributed computing, interactive analysis, and data visualization. And based on cloud computing technology, it also gathers remote sensing data resources and large-scale computing resources. Through an online, on-demand, real-time computing, it greatly reduced the time and reduce the cost for researchers and engineers and for any users who don't need to have like even a basic programming knowledge to complete the entire process. So up next is the sample structure. So based on those analysis that I just mentioned, we believe it's our responsibility to fill in the gaps between users and the feasible applications and provide more usable, more accessible, and high efficient and low cost products in this area. So PyEngine is our answer. It is a product system overall and is expected to fully provide one-stop services for remote sensing storage, for calculation, management, and usage, which can integrate all the remote sensing image processing technology with some other advanced technologies such as cloud computing, AI technology, big data analysis technology, and some others. So integrating all of them, PyEngine can allow users to have access to data storage, data management, data processing, data computing and processing, and finally to do some useful outcomes to achieve some useful products like information extraction, knowledge mining, sharing, and finally publishing to the world. So based on what I've just introduced, you probably will have a big picture of what this platform is capable of. So I'll move on to the target users, the typical users that we are facing right now. The target users of PyEngine we think, are mainly SaaS users, software as the platform software users. So these kind of users will include remote sensing scientific research, like they work in this field or they perform educational activities in this field, or they can be some employees from the related field companies, and they are doing commercial application or commercial business in this field. They mainly provide massive remote sensing data, dynamically scalable cloud computing power, remote sensing core algorithms, and real-time computing services. So the core algorithms and the real-time computing services are completely and independently developed in this platform. The services mainly include like basic remote sensing data processing, logical operations, index statistics, and analysis and reasoning to it. It provides users with a cloud plus terminal and a platform plus SaaS application mode, which means it combines the cloud and all desktop services together, and also put the platform and the software as a service together to create those applicational modules, and also gives full play to the advantages of high performance, low threshold, low cost, and easy access. So above all of that can allow to tap the actual value of the massive remote sensing data and help the industrialization of the remote sensing applications. So in terms of the user values, as you can see, we have categories that into three types. The first is for the universities and scientific research units or organizations. For them, we can provide free data, cloud computing power, and algorithm resources for their scientific research in universities or in scientific research institutes, and to realize the development of earth science research and to produce materials for the publication of papers and scientific research results, and also to support the teaching practice of the colleges and universities. So that is for the first group of our users. And for the second type, it is the SME users. The SME users, we provide them with a special products and online data production services. Users can obtain data results that can meet their applicational requirements without any industrial knowledge, such as remote sensing and the geographic information system. And at the same time, the platform can also provide users with a secondary development platform to support their small-scale projects, and such as in its development, in its collaboration with others, and finally have the outcomes published and shared. And for the third type of the users, for the industrial users, such as the ministers and the commissions inside this system, we can provide industrial users with integrated solutions of cloud service platforms, and also like private cloud deployment, and help them to conduct customized research and development according to their needs, so that this can meet their business application requirements. So this is more about customization. Up next to the second part, I will focus on some more highlights of the platform. This is the data structure of the platform, of how we recognize it. It is the core blockchain of technology that we use to perform the applications of industrial solutions. So this is the Pi engine, the overall structure that can be regarded as a comprehensive supply chain from data acquisition to data storage to data processing, and to finally use the data to create some more useful, more mature industrial products. So you can see above all, we have the Pi engine Earth. I'm going to come to that later. And after that, it is the it's actually the six major modules inside Pi engine platform. Then that includes the Pi engine studio, where remote sensing computing is conducted, the Pi engine factory, where the data processing is achieved, and we have the Pi AI, where the intelligent interpretation service can be performed in, and also can do like sample training. Users can perform their own works according to their requirements to train the AI and to do some artificial intelligent interpretation or something. And the Pi engine knowledge is someone drawing up on my screen. How do I remove this? Anyway, also the Pi engine UAV, which is another module that we specifically developed for drone application service, which has a very close relationship with the cloud computing technology. And finally we have the Pi engine server, which works as the data management service, and it is a mixed type of data storage strategy that providing users providing different types of access for users to the very huge database. Can I remove this? How this someone's drawing on my screen? Okay. Anyway. Up next, I'll move to where we have started creating this Pi engine, and of course, it's based on years of accumulation that we have created and developed in researching the Pi software, the desktop toolset. So there are here we have the Pi desktop software toolset, which is based on our independent parallel production underlying architecture, and it is developed by adhering to the design ideas of workflow, of component plug-in, multi-layer, and multi-module structure. And it has multi-source heterogeneous remote sensing images of spatial and ground data. So the Pi desktop toolset has the capability of processing fine 3D model construction, industry-specific product production, visual display of 2D and 3D data in modules, and also like more multi-terminal sharing and collaboration. I have mentioned all of this in the morning about our Pi software series, the desktop toolsets, and that includes the professional procedure for basic remote sensing image processing in Pi Basic, for satellite image mapping and the processing in Pi Author, for specifically for 3 types of data. For SAR data, we have that in Pi SAR. For hyperspectral and for drone data, we have that in Pi hyperspectral, Pi Hype, and Pi UAV. And up next, we have that scale set image analysis software integrated in Pi SciS, and we have geographic information system software in Pi Map, and also that can be applied for 2D and 3D modeling. And some new components that has been developed recently, like the Pi SDK, the Pi TD modeler, which are all related to spatial management and the control, or to TD model control and the building. So above all of that, we have emerged, we have concluded all the experience, all the achievements in Pi desktop toolsets, and integrate them all into what we have achieved next, especially when we put everything on cloud in the Pi engine. So our Pi engine takes the online coding programming as its main use mode and provides a complete online development environment that includes the resource search module, the code storage module, code editing module, running interaction module, map display module, and some other associated modules. Based on the some of its characteristics, including firstly, based on the cloud-native remote sensing service framework, this Pi engine platform provides a rapid acquisition of remote sensing spatial temporal big data, and also standardized storage management, efficient processing, intelligent analysis and application, knowledge mining and reasoning, and also data sharing and lifecycle one-stop data processing. Secondly, it comes with more than 160 types of data sets with a global with a total volume of 6 petabyte. As it actually has gone much further than this number right now, which covered the optical image data, radar image data, meteorological data, oceans data, geographic data, and vector data covering all around the world. And in terms of the satellites or the satellite series, that include like Sentinel series, MODIS series, Landsat series, and also some other high resolution series satellites in not just high resolution satellite, but also the resource satellite, environment satellite, meteorology satellite, and many other types. Thank you for clearing that up. So the third type is the third point is it provides millions of deep learning sample sets covering in terms of data type that covers the optical, SAR, aviation, and other multi-load, multi-resolution types of data. It supports the training of 3 types of deep learning models, and that they are the target recognition, semantic segmentation, and change detection. Fourthly, the platform comes with a cross-border integration of multiple technologies, of smart analysis, of border business, and also some other more realistic experience. Fifth, the platform also assures the dynamic and analyzable digital Earth, which is and the calculation results are presented dynamically, and the value of the simulation deduction can be found in real time. And lastly, this platform can create a new model of opening plus co-construction plus sharing module, and building the ecological concept of remote sensing cloud. So as a conclusion of this part, you can see after I think almost 2 years since we have established this platform, it has reached to a level that contains very multiple types of data and multiple types of algorithms, and already existed products that has been stored, and also with a daily increasing uploaded data, remote sensing data. So you can see it has a very huge library for all the users. ARPDEX are some of its core strengths, and that is going to be illustrated into 3 directions. So in terms of the algorithms, the platform now comes with around 300 operators, and in terms of the types of those operators, they not only include the general operators such as the full arithmetic operation, the spatial analysis, image calculation, but also include many other specific operators for certain satellites. And that is also what we think is another very great strength of our platform above the other its similar competitors in the market, such as especially for the supportability of those operators or algorithms over Chinese satellites, such as we have that for the Fengyun 4A series to Fengyun 4A satellite to calculate the PM particles and so on. And other than that, the algorithms from other mainstream platforms can also be transplanted to PyEngine Studio for further operation, and this process can be easily done. Up next is with its rich functions that provide for users, such as for the general functions, it supports all mainstream functions. And we actually do have a list, do have a form of all the functions supported on the website of this platform. You can check out later. And for the unique functions that mostly developed by PySet, it has been PyEngine Studio has been constantly developing new unique functions and adding to the platform, such as the service link integration, user integration, the batch upload, and many others. And in terms of the database, the total data volume of the platform is now 6 petabyte, and I believe the number has gone more after we calculated this statistics. And in terms of the types of data, it supports most major Chinese satellites and some other mainstream remote sensing satellite all around the world. Up next are some more outstanding features. The PyEngine platform has several superior advantages. One is with its powerful computing power, because the software is based on the on cloud platform, and the use of cloud computing power can highly improve users' work efficiency without relying on their own computer, on their own equipment. The second is with its rich data resources. PyEngine will access multi-source data in real time, and that include a lot of low and medium resolution data. Users will be allowed to directly call data without spending too much time on browsing various websites to download or taking up much computer's memory space. That is to say, you don't have to go anywhere else. You can have the work done on this platform only. The third is this platform is simple and easy to use. The entire interface adopts the commonly seen style in order to keep users familiar, so that they can be seamlessly transferred to PyEngine. The fourth is to display the results intuitively through the map display and icon display. The fifth is this platform is open for sharing and open to all public users, for the public access, it comes with free mode that allows users, especially for researchers, for educational participants, they will have a very great bargain in using this platform. And lastly, there are a wide range of research scenarios we support. So all of these scenarios has been created into examples or modules that users can directly deploy and to achieve similar results within no time. Up next, I'll move to the 6 PaaS, Platform as Service modules. And those 6 modules are, the first one is the PyEngine Factory, which is a standard product processing service. And the next one is PyEngine Studio, which is actually one of the fundamental, the indispensable part of the PyEngine. where you are normally expected to have your work done, have your data analysis. And the PyEngine Studio is for remote sensing computing services, very general but useful module. The third one is the PyEngine UAV, which is a module specifically for the drone application services. And as I mentioned, this drone application is also has a very close relationship with cloud computing and with others such as urban management, with emergency rescue and response, and so on. So it has become one of the major focus in the platform. And fourthly is the PyEngine AI, an integrated interpretation service allowed by AI technology that allows users to do the sampling, the sample training, and to use them to achieve some of their unique performances. And up next is the PyEngine server, which is a data sharing services, and such as that comes from data configuration to template creation to data editing, and finally have your results published and shared. And finally is the PyEarth, which is a visualized smart Earth application. So I will spend more time on all of those 6 modules, and we'll start with the PyEngine server. The PyEngine server data sharing cloud services. It is a spatial data service, and it is a service platform for managing and sharing geographic, temporal, spatial data, and also an application development support platform for building web applications. It has the ability of resource integration, centralized configuration, and overall management of multiple types of data, such as multi-source massive satellite images, aerial images, oblique photography models, elevation products, basic geometry, meteorological data, ordinary files, and web standard services, many other kinds. For like enterprise or public users, this platform can not only provide private multi-source heterogeneous data storage, cataloging, query, distribution, publishing, visualization, and sharing capabilities, but it also provides public free data resource query, download, publishing, online mapping, and sharing capability. This will allow open APIs for the enterprise users to build various web applications and to realize business data integration, and also provide service support for the upper-level industry applications. So this is a general workflow that how PyEngine can provide multi-platform for online mapping and publishing. And that can be supported in many ways, such as that can be done on the web and can be created in a client or a desktop version software, and also can be used to develop a mobile app for the information publishing and sharing. So it will start with the data configuration and to create template and categorize all of those information into types, and you can give labels on it. And after that is some fine editing inside the data, and finally have the results published and shared. The second one, the PyEngine Factory. The PyEngine Factory data processing service is a distributed processing platform that provides a standardized product production, management, scheduling, and quality inspection integrated services for the mainstream remote sensing satellite and aerial photography data. This platform provides a rich algorithms and the product line templates to support the automated and production in the large volume of image data. Standard products such as the optics, the optical, the hyperspectral, SAR, or the like the inversion of the ecological parameter products, the intelligent extraction and information mining of classified products and service elements. And it also supports the quality inspection and accuracy elevation of the above products. Up next, the third module, a PyEngine AI module, which is we call it the end-to-end, the code-free, full-stack remote sensing image intelligent interpretation cloud service. It is based on the public cloud elastic GPU resource and storage resources. The platform is based on online multi-personal collaborative labeling and also the management of massive remote sensing image samples. And those combined with the millions of professional remote sensing sample data sets and also the rich neural network modules suitable for remote sensing interpretations. So with the help of a unique computing resource pool and the heterogeneous data storage pool, above all of that, integrating all of that, this PyEngine AI can provide users with a one-stop solution covering the from sample annotation, model training, model release, interpretation application, and finally to the resource sharing, and reach the rapid development of various types of AI models. And that include such as target recognition, semantic segmentation, change detection, and also remote sensing intelligent interpretation, and so on. Through the combination of spatial information technology and also the artificial intelligence technology, this PyEngine AI integrates deep learning theory with remote sensing interpretation practice and comprehensively improves the intelligent processing and interpretation analysis capability of a great deal amount of remote sensing data. So that's next step. Next slide shows what you can expect in a typical AI model training. That you are expected to start with the AI with the data import to data analysis, and up next is to extract the information, the characteristic information that you want from the data, and finally to generate the visualized results based on the process. This is another example using the AI technology to do the interpretation online. And what you are looking at right now is some information statistics for the ground feature, like different types of ground feature. Ground objects are marked in different colors, like that for buildings, for bare land, for grassland, for roads, for forestry, for vegetation land, for farmland, for water bodies, and the others. And all of them are marked in an individual color so that you can have a very big picture of the ground information statistics, and you can have more information such as the numbers, the amounts of different parcels, and the areas of each parcels, and the calculation of the overall picture, and how much percentage of each kind of ground feature is taking part of. Up next is the PyEngine Studio, which I mentioned is the module that you are expected to do most of the work, remote sensing data processing work in. The PyEngine Studio Remote Sensing Computing Service is an online remote sensing cloud computing platform that integrates massive geospatial data and interactive programming analysis and real-time distributed computing and data visualizations all together. It is the most important part of the PyEngine family. It is mainly designed for remote sensing scientific research, participants, or educators, or engineering, or for technical personnel and related industry users. But as I mentioned, it's also available for anyone. And it does require some certain level of coding capability, but not much. The platform provides a complete online development environment, and through the either JavaScript or Python scripting languages, users can call massive data and computing resources for a real-time computing and analysis of large-scale geographic data, or study algorithm models at any scale, or take interactive programming verification to achieve rapid exploration on the surface features or any other purposes. So based on the cloud computing technology, PyEngine Studio integrates the elastic computing power, the massive data, and the analysis algorithms, all of them into one. Users can quickly realize the whole process from remote sensing data preparation, distributed computing, to visual rendering through simple programming. It reduces the time spent, and the resource cost of remote sensing research for users, so that the users can more focus on the research of remote sensing theoretical models themselves, and the application methods, and that generate more usable scientific research value and engineering value in a much shortened time. The development and the application of PyEngine Studio will accelerate the rapid formation and the rapid development of remote sensing technology ecosystem. So as you can see, the PyEngine Studio comes with two types of transcript that you can have either choose to do that in JavaScript or Python, and it will be much better if you already have a background in these areas. But if you don't, you can still get a hang of using it after a quick learning. So this is the interface of the PyEngine Studio. On the top it is the resource search area where you can type in any type of resources, any type of or the name of the data resources or any location that you are interested into, and you will be able to find some results already stored on the platform. And on the left, we have the script function area where you can have you can search for some algorithms, some functions, some scripts already existed, or some resources, some achievements has already been created either by Python already stored there or by someone else who have uploaded their work, and you will be able to find them there. And in the middle, it is the code editing area where you will have to use some JavaScript or Python languaging capability to write some code and have your work pilot and have it done. And on the left, you are expected to see the result output, like the current information has been loaded, or the result has been partly or displayed in under current steps or the missions you are after right now. And down below it is the map display area. So when you are dealing with remote sensing data, you will always have them displayed on map because that has a very close relationship to the location to where you are looking at. And there are some other menus, some other buttons, like you can switch the plot vector, you can change how the map is displayed, and you can switch to a different layer or switch to another map resource. This shows this slide shows an example of the vegetation index calculation, which is based on the Landsat 8. And you can see in the picture where the calculation of the vegetation index is calculated and displayed for the entire area in China. So it allows a wide range of image analysis, and that is to say the platform can perform the cloud removal processing, the aggregation calculation, and the rapid splicing of thousands of images within seconds. And that can be a very huge difference from what you got if you choose to do that on your own computer, because the computing resources is very different at different scale. And if you have access to these cloud computing resources, the benefits are you don't have to originally have the data that you want to focus on, because most of the data, mainstream data, are already stored in the platform. And you will be able to deploy all the computing resources on cloud. So that means the computing speed for processing massive data can be much faster than what you can achieve on a single computer. So up next is the PyEarth, which is a geoscience natural environment visualized smart Earth application, and it is based on the concept of data-driven, the real-time perception, the multi-source fusion, independent, controllable, and other concepts. It has been applied to visualize the 2D and 3D visualized display and the intelligent analysis application of the PyEngine cloud data. So it can use the cloud plus service plus multi-platform working mode, and help users to have a much much better visualized result of the data that you are working on. So here's some example of the visualized display of marine disasters that you will be able to observe the multi-source fusion, the data-driven, real-time perception, and independent and controllable, all those features of the data, and have them displayed. I actually have some examples, like what you can expect when you want to display a port in 3D, when you want to have perform a meteorological simulation, and or a customized environment construction. So all of these scenarios are can be customized and can be achieved by using this platform, using PyEarth. Some more vivid examples, like on the left, shows the marine disaster risk level throughout the Chinese coastal line, and have the risk level marked in different colors. And on the left, it shows that a dynamic visualized display of tsunami disasters, where you can see the different contours to express the different levels of severity that has been impacted by the tsunami. The final module in, let's see. The final module in PyEngine is the PyEngine UAV application cloud service, specifically for drone applications. It is a customized cloud service platform that focused on the UAV imaging products and monitoring products. This platform realized the rapid import of photos, automatic algorithm processing, and one-click automatic cloud production of large-scale images, and combined with the needs of multi-industry UAVs to realize the construction of cross-industry UAV applications with deep integration. This PyEngine UAV is combined with the app, which can build a full lifecycle application environment for data acquisition, transmission, and processing, and also support the rapid production of orthophotos, of DEMs, and 3D models, and integrate the AI deep learning models to achieve the intelligent target recognition, statistical analysis, and high quality normalized monitoring. This is the interface of the UAV application cloud service, where you can see the scene gets displayed for the tilt model production using drone data. In the final part, I will give you more on some real-life cases. The first is with some examples of remote sensing cloud platform. And there are 4 boxes shown for 4 different industries, in which the cloud services are considered to be the very mature and has already been widely applied. So the first is with natural resources. Based on the remote sensing cloud platform, the basic information system of land and space, and the dynamic monitoring, the evaluation, and the early warning management system of land and space planning have been developed to provide land and space planning services for the natural resource industry. And for the second example, it is for the maritime, in which the establishment of marine environment information system based on the remote sensing cloud platform and provide users with full process solutions for marine informatization, and that also include the marine satellite remote sensing, marine observation exploration, marine numerical forecasting, and other multi-source data collection and analysis, and also quality control and standard data set production, fusion analysis, statistical analysis, and comprehensive visualization display, and etc. The third one is for the emergency detection and rescue, and where the intelligent detection of disaster can be achieved, and that can be very useful for monitoring natural disasters, or monitoring fires or floods or disaster, any kind of that, and also helps with the quick response, quick react to the disasters. Fourthly is for the environmental protection, which is based on the remote sensing cloud platform. This environmental protection fully combines the satellite monitoring, the drone monitoring, ground surveys, and all of those together to provide a monthly monitoring results of urban black and Ordos water bodies, and provide information support for such as the on-site law enforcement, and in terms of the black and Ordos water bodies, PISAT has been providing that kind of services for the Beijing municipal for monitoring that for 2 years already. Some more examples of the remote sensing cloud platform, such as that can be used for land use and change detection, and for ecological environment monitoring and control, for forestry, and for smart agriculture, for the governance and monitoring and the supervision of these areas. Also for emergency detection, like the fire, for flood, for disasters, for post-disaster reconstruction, or post-disaster damage analysis and statistical results, and also for water management for water-related disasters, and also for water resource. So taking this analysis of vegetation coverage in Beijing as an example, you can see that there are basically 4 steps. The first should be use time and regional conditions to filter and obtain the multi-temporal Landsat 8 image. Taking Landsat 8 image as an example for the data input, and use that for more than 40 scenes to realize the cloud removal fusion based on the cloud cover band. And then up next, we can use that result to calculate the NDVI index for the result. And then we can calculate the crop. We can crop the final result with the Beijing administrative division vector, and you can see more on these steps. So this is the first one where you call for that Golden series data in Landsat data in Beijing, and use that to calculate the NDVI factors. And in this one, where you can use that factors, and where you load the boundaries of the Beijing municipal area and have the results displayed. So now you have the um, um, vegetation analysis based on NDVI calculation in Beijing. So this is just a very simple example of what you can achieve in PyEngine platform. There are more examples of what you can use in remote sensing cloud platform. And this picture can, I think, explain a lot in what you are expected to do in here. Based on such enormous capability of this platform that is capable of doing, the future of more international cooperation is quite promising, we think. And we are always open to a win-win collaboration with anyone who has the interest in such technologies and aims to generate much more benefits for the livelihood of people, of the society. All right. So this is the end of the introduction to the platform. But other than that, I would like to spend a few more minutes on of the platform. So this is the interface of the main interface of the platform itself. I'm very sorry it's still in Chinese, and I can explain that due to there's a lot of restrictions, a lot of policies towards like data exporting, because our platform comes with a lot of remote sensing data already installed, very huge amount of those, and most of them are from mainstream satellites all across the world. But on the other hand, a lot of them are from Chinese satellites, and the Chinese government, have a very strict policy on that, on the data export. So we have been running this Chinese version of PyEngine for, I think, for around 2 years, and we have achieved a lot, accumulated a lot in here. But we also want to promote this technology to the world so that anyone else from, not just from China, but also from other countries, can have access to this very, very excellent technology. If you are a Chinese user, when you log into this site, and you will be able to immediately do some programming in the PyEngine Studio after you log in. But on the other hand, I have to explain that despite the fact that currently we don't have the English version officially released for users outside China, but the positive news is, I can share a bit more information with you, is that starting from the beginning of this year, of 2022, PySet, along with some other partners like the Aerospace Information Research Institute, Chinese Academy of Science, and also other two universities from Beijing. One of them is the China Capital Normal University, and the other is the Beijing University of Civil Engineering and Architecture. So the four of us, one company and the other 3 partners, we have already started working on a project, a research project, which is funded by the Ministry of Science and Technology of China, and the project is its name is, let me see, its name is called the International Promotion and Application of One-Stop Remote Sensing Big Data Online Analysis Platform. So the fundamental of this project is to reconstruct and customize this platform our platform PyEngine, but also with contribution from the AIR based on their best cloud engine, best cloud platform. We want the two platforms to merge together and provide more professional applications, and also for not just for research, for general data processing, but also largely for the educational purpose. So we want to merge together and create a new platform so that this new platform can satisfy the requirements for users all across the world, but also carrying most of the advantages, most of the core strengths that I have introduced based on PyEngine. This platform, this project is going on for, is planned to going on for 3 years, 2022 to 2024. But I'm sure you, if you are interested in PyEngine and also want to have an English version, especially when you're not Chinese, you cannot have access to the Chinese version. It will come soon. That's all I can share with you. For users all across the world and want to have access to remote sensing data processing on cloud. Okay. Oh, I think that's all I want to share in for today's training for Pi software application and also for the PyEngine cloud remote sensing cloud service platform. And also thank you so much for your listening. Thank you. I will share the instructions document in our space, and also share another. I think the recording of today's training will be available to you also. So thank you all. If you have any further questions, you may contact us through our email links or to our website for further information. Thank you.